I am now pleased to introduce my colleague and friend, Aerial Services President and CEO, Mike Tully, who will share his expert knowledge with you today. Serving as President and CEO of Aerial Services, Mike's duties include managing company endeavors, supervising GIS programming, and overseeing the company's information technology and technical resources. Mike has managed the company as co-owner since 2000 and was named President and CEO in 2003. He is also a certified programmetrist, a certified geographic information system professional, as well as an active member of the Management Association for Private Photogrammetric Surveyors, MAPS, where he sits on the board of directors. Mike is a technologist and always keeping an eye on trending innovations. UAV are no exception, and with his guidance, Aerial Services has been active in researching and understanding how these new tools will affect remote sensing. So with that, I am happy to turn over the session to Mike Tully, who will get on with the show.
Okay, well, thanks, Josh. Appreciate it. Thank you, everybody, for coming. We're here today to talk about unmanned aerial systems, or UAS, also referred to by others as UAVs, or unmanned aerial vehicles. You may hear me use both terms interchangeably. I like to refer to them as UAS because they are flying systems, not just aircraft. It's right that we talk about these today because UAS are in the news continually now, and for many of the right and wrong reasons. I hope today to share with you, with each of you, what I've learned about these amazing technologies, how they're impacting our work today as geospatial professionals, and what they may bring to the future of geospatial solutions. Josh, excuse me for a minute, but I'm having a technical issue here. There we go. Solved. User error. First, I guess I should have a disclaimer that I'm not a seer. I can't predict the future with much accuracy, but I have taken a special interest in this area since learning a few years ago the amazing things this technology was accomplishing overseas militarily, and realizing that much of this technology is migrating back to the States, where it promises to have a profound impact on geospatial markets and opportunities. I've pulled together a tremendous amount of material from a large number of sources for this presentation, and at the end of the slides will be a list of references and citations used for the presentation. All of this material will be posted on our website for use after this broadcast. So I thought it best to frame the presentation today by describing the size of the UAS market. The Teal Group is a Virginia firm that tracks the aerospace and defense industries and estimates that the global market for unmanned aerial vehicles will nearly double over the next decade to about $11.4 billion. Much of that growth will come in the public and private sectors as the military budgets are reduced. International spending, meanwhile, will more than triple over the next 10 years. The Teal Group noted in their report that UAS is the most dynamic growth sector of the world aerospace industry this decade. A second firm, Wintergreen Research on the right, has made similar predictions back in February 2011. They estimated that the UAS markets at that time to be about $2.5 billion and forecasted them to reach $7 billion worldwide by 2017. Growth will come as the lighter and less expensive aircraft begin performing commercial tasks remotely with less cost and more versatility than is available in any other manner. Note, though, that these figures are estimates only of the unmanned aerial systems market, not all the other industries that will likely expand and develop because of them. A market of this size does employ a great number of people, and I do not have good numbers on how many people are employed, but I'm sure that's a sizable number and will grow substantially as UAS are deployed in a myriad of uses in the coming decade or so. In Southern California alone, there's an estimated 10,000 state residents that are directly employed in the drone sector at 3 of the largest drone manufacturers located there: General Atomics, Northrop Grumman, and AeroVironment. For comparison's sakes, the current size of the UAS industry is pictured here relative to other industries we are aware of. The solar power industry in 2010 was just $69 million compared to the wind power industry at $3 billion and mapping and surveying at $7 billion. The really intriguing aspect of UAVs is the combination of several key technologies into a single autonomous robot. That's the marrying of GPS plus IMU plus a camera and other sensors plus a pilot and sensor operator plus a CPU and communications into a single autonomous vehicle. For those of you listening that are not familiar with all these terms, GPS devices give us position, and the IMU tells us which way the sensors and the aircraft are pointing. Together, those two devices enable us to precisely position in space the aircraft and the data being sensed. This combination of technologies is truly sensational, but it's also a little scary. Imagine a firm like Aerial Services. Today, we fly all around the country with manned aircraft, usually with a pilot and sensor operator on board, and collect highly accurate 3D geospatial data. Now, suppose in a few years, using UAVs, we'll be providing high-res orthos and LiDAR for a 500-mile pipeline using a single operator, not in the aircraft, but sitting in our offices in Cedar Falls, Iowa, flying an aircraft that takes off and lands in the parking lot of our office. We won't need an airport anymore. A parking lot anywhere will do just fine. But that's not even the most interesting point. The really interesting and scary thing about UAVs and the future of remote sensing is to imagine the pipeline company using the UAS to map their pipeline and not using a professional services provider at all. The history of innovation and changing technological paradigms informs us that many of us listening to this conversation will not be able to understand how this disruptive technology will change the delivery of not just data, but geospatial solutions. It's not just about aircraft and sensors, but we will now see real-time communications, cloud computing, and robotics coming to bear and bring a whole new dawn of geospatial and remote sensing solutions. Current business models will certainly be disrupted. So what happens when we get accurate high-res orthos and elevations straight out of the can, from the aircraft to the cloud to the customer? And we can accurately image every corn stalk in the field, multiple times each year for a fraction of what it costs today. Or what happens when we have 168 hours of real-time high-definition video each week that shows the location of every and each type of intrusion into a defined corridor, a pipeline or a power line or some other type of corridor? What happens when I can update my web service running at the office in near real time with highly accurate orthophotos and elevation models using dozens of inexpensive autonomous flying cameras flying over my county or my state? But they're not just dumb flying cameras. They're intelligent and listen to weather feeds. So these flying cameras know about the weather and automatically take off and fly over the whole city or county whenever the weather's nice, and continuously post intelligent updates to the base map running on the county web server, for example. What happens when virtually anyone can fly an inexpensive flying robot sensor and produce geospatial information, and it's no longer left to a few dozen specialized remote sensing firms? What kinds of new opportunities will all this create? What impact will this have on traditional remote sensing firms? History says that nearly all of us listening today will not conceive of nor understand how to exploit the new opportunities created by these developing technologies, because we're bound up in the way things are and always have been, and we won't see how to do these things creatively and completely differently. Nicholas Carr wrote an interesting book a few years ago called The Big Switch. He described how shortly after Thomas Edison first built factories in Chicago that produced and distributed this new thing called electricity, that a whole new paradigm of power was created. At that time, most manufacturing plants built their own small hydroelectric plants and hired a myriad of professionals to produce their own electricity. But after Edison built that plant in Chicago, manufacturers could buy abundant, cheap, reliable energy off the grid. Their hydroelectric plants and staff became dinosaurs almost overnight. But this new, cheap, abundant power also disrupted all kinds of other things. Now homes had cheap, reliable electricity. A myriad of electric home appliances were conceived, like microwaves, and TVs, and washers and dryers. More importantly, computing was now possible because of inexpensive, reliable energy. Now, 100 years later, the entire world has energy, and 1 billion computers are talking to each other continuously across the World Wide Web. The paradigm for electricity changed and spawned new technology, wiped out others. Those electrical and mechanical and hydro engineers creating water wheels for electrical power generation could not adapt. They were worried about losing their jobs and watching their profession die. They were bound up in the old paradigm. I believe the effects of this transition to autonomous flying sensors may ultimately change the geospatial profession as profoundly as cheap electricity changed society and led to the World Wide Web, and will fundamentally change the way we work and play. What billion-dollar markets based on this disruptive unmanned technology are about to blossom that geospatial professionals can benefit from? Will any of us own manned aircraft 20 years from now? Will any of us that now own manned aircraft be able to adapt and exploit the changing paradigm? A good example from our recent past may illustrate this point. Aerial Services was an early adapter of GPS technology. That's the technology that we hold in our hand today that tells us where we're at on the planet. It was great. It facilitated much more accurate and efficient mapping. Few people could do that similar. It gave us a competitive edge. But then something unexpected happened. GPS devices got smaller. They were easy to operate. They were inexpensive, and our clients began buying them. Then they began to map their own stuff instead of employing us. A good portion of Aerial Services mapping work evaporated because our clients did their own mapping. They no longer needed mapping professionals to map many of the small areas that we had traditionally mapped for them. They could do it themselves. UAVs will likewise be an enabling technology that will disturb our current business models. So why are we having this webinar today? In this summer webinar series, we've tried to present relevant information about professional services important to us, our clients, and our geospatial profession. The first two topics earlier this summer on LiDAR and positional accuracy are extremely important and relevant topics for today's geospatial professional. They undergird almost everything we do. This final webinar about unmanned aerial vehicles has much less day-to-day practical applications today, but looking forward is so important and exciting and promises to be such enabling and disruptive technology that professionals need to really get it now and understand and begin to plan and strategize so we don't miss out on exciting opportunities that are coming. Today we'll cover these broad topics: the history of UAS, the current environment we find ourselves in, and a little bit about the future. Unmanned vehicles are not anything new. One of the earliest uses of them was during World War II. At that time, German military planners had an eye to use homing pigeons carrying small 40-gram cameras on their chests to take pictures of the enemy. Interestingly, these early UAVs share the same attributes with modern UAVs that make both incredibly useful. First, they were autonomous flyers. They were capable of dull, long-distance, long-endurance flying. The pigeons and our UAVs today can avoid hazards. They were reusable, and importantly, they cost less to build and to fly than other means. Then in 1960, Gary Powers was shot down and captured in the Soviet Union while flying our super-secret U-2 spy plane. This wasn't a UAV, but it's important history for a couple reasons. First, this event marked the end of an era, manned spycraft. It was becoming too dangerous with modern weaponry to send men into hostile territory to spy. The military began working on this problem about that time. And in the late 60s, the military was flying early drones like the Firebee, pictured here on the left. In 1991, the Persian Gulf War, during the Persian Gulf War, a more capable aircraft, but still a very early UAV called the Pioneer, was used for intelligence, surveillance, and reconnaissance, targeting and battle assessment. The Nat 750, not pictured here, built by General Atomics, was first used in Bosnia in 1994 and was important because it could fly to an operational area from 1,200 miles away and loiter above the battlefield for 12 hours before returning home. By the time of the 9/11 attacks in 2001, the military was using less than 200 UAVs. Then came the war in Afghanistan. The first Global Hawk, a modern UAV, was flown there in 2006. This aircraft has seen a number of incremental design upgrades since then. Many other types of UAVs with very specialized capabilities have been developed since then in Iraq, Iran, Afghanistan, Yemen, Somalia, and other parts of the world. Today there are over 7,000 UAVs operational in the U.S. military. To date, UAS have been used primarily for military intelligence, reconnaissance, and surveillance, and kill missions. But today there's a growing use of UAVs among other government and educational agencies. The FAA refers to these flyers as public operators for things like police work, fighting fires, border patrol, agricultural research, and many more things. Public operators are folks like NASA, DHS, NOAA, and other state and federal organizations. Today, these public uses of UAVs are allowed if the entity applies for and receives a certificate of authorization, or COA, first from the FAA. UAV operators are not allowed to fly UAVs without first obtaining this COA. Between January and July this year, FAA had issued 201 COAs to over 100 different federal, state, and local entities across the United States, pictured here. And the number of COAs being issued annually by the FAA is increasing dramatically. The regulatory hoops that entities must go through to get a COA are complicated, but are being more streamlined today by the FAA. So what once took 3 to 4 months now just takes 30 days, I'm told. I've not tested that, but I'm told it's much more efficient today, which is good. UAVs are used by these different public agencies and universities for many interesting projects. For example, sensing highly toxic environments like volcanoes and nuclear reactors. We saw them used in Japan after those nuclear reactors were flooded. Environmental monitoring, emergency management functions, Arctic fisheries research, conservation. Greenpeace uses them to surveil whaling ships. They're used to observe wildlife. They're particularly suited for this since they're very quiet and don't disturb the animals as conventional aircraft do. A Dutch firm builds drones that fly by flapping wings and are disguised as falcons and hawks and are used at airports to scare geese away. Within the last few years, the U.S. Army Corps of Engineers have rapidly increased their use of unmanned systems. These systems provide actionable, on-the-ground information to help cost-effectively maintain vital national infrastructure by using them to conduct high-resolution bridge and dam inspections and inventory waterways containing invasive plant species, for example. The Nano UAVs is routinely deployed stateside for the U.S. Army Corps of Engineers Jacksonville District to support the invasive species program, Everglades restoration program, and some other programs down there. Last winter, I saw some televised downhill ski racing filmed from a UAV flying just ahead of each skier as they raced down the mountain. A unique perspective indeed. Today, and over the next 5 years, we will see an important transition from heavy military development of UAVs to development for public and civil markets. Military budgets for UAS are shrinking due to sequestration, budget cuts, and the fact that the wars seem, today anyway, to be winding down. It is not possible to understand the UAV's environment today without talking about the regulatory environment that governs the use of UAS in the national airspace. The Federal Aviation Administration is responsible to ensure the safe operation of all aircraft in the national airspace, including UAVs. For those of you listening that aren't familiar with that term, the national airspace is basically the sky, everything above the ground and not in outer space. This graphic depicts the different types of airspace the FAA has defined. Operating UAVs in U.S. civil airspace requires an extraordinary amount of regulatory cooperation, including a certificate of authorization that we've talked about that precisely defines the timing, routing, and operations of the UAV in the national airspace. Today, the FAA does not allow UAVs to be used for commercial purposes. Only public entities can fly with COAs for research purposes. In many other areas of the world, like Canada, South America, and Europe, for example, UAVs are allowed in the skies for commercial purposes. The United States is behind the curve here, and the FAA is trying to catch up, but their chief concern has been and still is to ensure a safe national airspace. These public agencies can operate unmanned aircraft today if they weigh less than 20 pounds, if they're flown within the line of sight of an operator, flying less than 2,000 feet above the ground, and during daylight conditions, among other things. The FAA's congressionally mandated framework for the safe integration of unmanned systems into the national airspace is contained within the FAA reauthorization bill enacted into law just earlier this year in February. This bill mandates that full integration of UAVs into the national airspace must be accomplished by September 2015, just 3 years from now. But it also stipulates a number of a number of other important milestones along the way shown here. By May 2012, just a few months ago, the FAA was to release rules that allowed first responders and law enforcement to fly micro UAS, or those under 4.4 pounds. They did accomplish this, and we're witnessing a growing number of police and emergency management personnel begin using these small UAVs. This has coincided with a large number of Fourth Amendment privacy concerns reported in the press. We'll talk more about that in a little bit. Then by the summer of 2012, we were anticipating rules for small commercial unmanned systems, systems less than 20 pounds. The FAA is currently in the process of developing a set of rules that would enable the routine operation of small unmanned aircraft. While this is a major development that might enable the operation of UAS for commercial purposes, the new rule may apply only to aircraft operating in the visual line of sight, weighing less than 20 pounds, and operating in the daylight under good weather conditions, and flying only over rural areas. We don't know what the rules will be because nobody's seen them yet, but those are what they may look like. By August 2012, that's now, the FAA was to release the RFP for the designation of 6 unmanned aerial test sites. These are really important early steps to achieve full integration into the national airspace, because these 6 test sites will help the FAA test, train, and collect data in a variety of different environments and conditions to facilitate the safe integration of these vehicles into the airspace. The 6 sites will allow UAVs to operate with relative freedom, and the data will be used to, help integrate the airspace at large later on. The FAA has not met this deadline, and I just read earlier this week that this RFP may not be released until after the November elections. But already there is growing activity to build supporting industry in areas around the country that hope to be designated as one of these 6 areas. Economic development agencies in states and counties are already working to bring UAV businesses to bear on local jobs and economies. For example, the University of North Dakota has created the UND Aerospace. This program has several goals to first create a world-class infrastructure for UAS development, testing, and evaluation. They want to create the finest training program of its kind anywhere in the world. In fact, they've already created the first bachelor's program for UAV piloting. They want to promote commercialization of new UAS-related products and services. They want to promote the private job sector growth within Grand Forks and throughout the state of North Dakota. So designation as one of these 6 test areas is a big deal in many areas vying for this designation. November 2012, the FAA is to release the full integration plan, just kind of an outline, the details about how they're going to accomplish that. August next year, in 2013, a special milestone in this bill is the designation of new types of airspace defined over the Arctic that will allow small unmanned systems, those under 55 pounds, to fly 24 hours a day beyond the line of sight at an altitude at least 2,000 feet. Then finally in September 2015, skipping over the 2014 milestone momentarily, we should see the final and full integration of the unmanned systems into the national airspace. But before this can happen, new technologies are needed to overcome a couple technical limitations that impact unmanned objects flying through national airspace. First, these aircraft will need technology to sense and avoid other intrusions into the aircraft's flight space. These systems will be smart enough to make sense and take evasive actions with or without human intervention to avoid collision with something. The earliest sense and avoid systems will probably be ground-based, But as this technology matures, each aircraft will contain all this equipment. The second big need are communication systems that can provide uninterrupted command and control for the UAS. The safe operation and routine integration into the national airspace just can't be achieved until aircraft operators are confident that they know where their unmanned vehicle is at, what its condition is, and if they can control it. Going back then to the May 2014 deadline, small UASs are to be fully integrated into the national airspace. This will be an important milestone because if it is met, this will be the beginning of widespread commercial use of small UAVs. This is when the UAV-related markets will really begin to materialize. I want to divert for just a minute and clarify the size classifications that are becoming defined in the industry. We've used several terms like micro, small, and large, and this is just kind of a quick description of what those terms are beginning to be used to mean. There are some very interesting uses of these nano UAVs envisioned. These are tiny insect-sized aircraft. The military envisions these tiny robots to lie in secret until needed. They can be equipped with incapacitation chemicals, combustible payloads, or even explosives like small bullets for precision targeting capability. I wonder how long it'll be before the next Bond movie shows these tiny assassins taking out the next evil mastermind. Stuff like this wasp, dragonfly-sized Delphi. Let's see. All of these technical and regulatory changes are critically important because growth in the non-military UAS market is unlikely until regulations allow for the routine operation of UAS. Will the FAA meet their deadlines? If not, what impact could that delay have on development of commercial industries and professional services around unmanned vehicles? These are all unknowns for now. There's a lot riding on the successful integration of UAS into the national airspace. So we can't possibly treat the subject of UAVs fully without discussing the very passionate and very current issues concerning privacy and remote killing that have come to our attention in the last 6 months for sure. Civil libertarians and others have raised legitimate concerns about the growing use of UAVs to surveil Americans, especially during the early adoption phase of this technology. There is still very uncertain legal precedents for their control. The issue centers around being spied upon by unmanned vehicles, aerial vehicles. We all know that police helicopters and manned aircraft have been used for decades in the skies over American citizens, and we are generally acceptance of those, and we don't look upon them suspiciously. But the main concern with UAVs in the skies over our heads is that unlike helicopters and planes that are manned and easily seen and heard, a drone is not. You don't know when you're being spied upon, and this really upsets some civil libertarians. Several high-profile press accounts this year serve to illustrate the concerns here of the public. The EPA was thought to be using UAVs to spy on Americans out west. In another case, a rancher was arrested earlier this year after police observed his position using an unmanned aerial vehicle. The ACLU has expressed concern that giving UAVs greater access to U.S. skies will result in, quote, a surveillance society in which our every move is monitored, tracked, recorded, and scrutinized by the authorities, unquote. These intrusions of our privacy do not only come from UAVs, however. We are remotely sensed every day, for example, by thousands of traffic cameras. It was announced last week that New York City just enabled the Domain Awareness System. This system uses data from a network of 3,000 cameras in lower Manhattan, brand new system, and allows cops to access information from live video feeds that could potentially show who left a suspicious package behind just moments later, or get a reading on radioactive substances as occurring naturally, or perhaps it's a weapon or just a harmless isotope laying around. It will enable authorities to track where a car associated with a murder suspect is currently located and where it's been over the past several days, weeks, or months, or check license plate numbers to a watch list and alert investigators if a match is detected. In a rather chilling admission from a spokesman for the New York City Police Department, he said, quote, "This is a system developed by police officers for police officers. Privacy advocates are sufficiently alarmed." A similar system has been deployed in Gardenia, California, and it's intended they be deployed other places. But wherever and however privacy is threatened, we are wise to remember that UAV technology, any technology, can be used for great good and great harm. Ultimately, the application of drone technology is a human choice. Regardless of the technology, bad people will use it for bad things. We should not be talking about banning drones, but banning the misapplication of UAV technology. UAVs are already demonstrating their potential for great good. It will be to our collective great loss if the baby's thrown out with the bathwater. These concerns are resonating on Capitol Hill. Recent bills in the House and Senate include one from Edward Markey, Democrat from Massachusetts, that would require private drone operators to inform the government of any data collected by drones, and that law enforcement is to minimize the collection of information and data unless it's crime-related. Rand Paul, a Republican in Texas, introduced a Senate bill called Preserving Freedom from Unwarranted Surveillance Act. This bill would require the government to get a warrant before using aerial drones to surveil U.S. citizens. More recently, last week in fact, the nation's police chiefs adopted a code of conduct for their use of drones. This code of conduct stipulates that any images captured by unmanned aerial vehicles would be open to inspection by the public, and that the images not be stored unless they are evidence of a crime or part of an ongoing investigation. Further, that if they plan to fly drones over an area where they're likely to spot criminal activity and where they might be intruding on someone's reasonable expectations of privacy, that they should seek to get a search warrant first. The Maine Association for Unmanned Vehicles, AUVSI, came out a couple weeks ago backing a voluntary code of conduct for UAS operators, which includes a provision to respect the privacy of individuals. These are all very positive developments that will help avail the public fear that this as yet unfamiliar technology will not be used to violate our Fourth Amendment rights to privacy. Remote killing has come up recently, especially after Anwar al-Awlaki's family, all of which were American citizens, sued the government for wrongful deaths in Yemen after a UAV took him and his 16-year-old brother out. They were both American citizens, and there's no precedent for our government targeting its citizens in this way, according to the ACLU. The suit asks, does the government have the authority to kill its own citizens without acknowledging its actions? If so, it could be abused by future presidents. The government's position is basically that the deliberations carried out within the executive branch without oversight by the judicial branch over the question of whether an American citizen could be killed without judicial process counts as due process. That is more than a little scary for many Americans that value their freedom and their life. I wanted to take a minute, too, to discuss in more detail small unmanned aerial vehicles. These are aircraft smaller than 55 pounds. These aircraft will be the first area of real civil interest because these are the type of UAVs being used today by the public entities and will be first used commercially perhaps as early as 2014. The industry is awaiting the FAA to release rules governing the use of these small UASs in the national airspace. The rules for governing their use are expected soon. No one has seen these rules, so no one obviously knows what they are going to say, but they may specify that they be used only under 400 feet in Class G airspace, only used in line of sight. They may or may not require sense and avoid technology, and there may be others there also. Aerial Services recently completed a comprehensive compilation of small unmanned vehicles, sensors for them, and processing software available in the U.S. for civil purposes. We purposely did not include in this inventory systems designed and sold primarily for military purposes. All of these aircraft share some common components. For example, they all have an autopilot, a GPS, sensors, an IMU, an aircraft of some sort, a ground communication system, and some type of wireless communication for video and other things. We've identified about 168 different models shown here, made predominantly by U.S. firms, but at least half are made and marketed by firms in many other nations, including Israel and Germany primarily. Although we don't have time today to look more carefully at this data, it has revealed a great deal of interesting information about this market. I plan to share more about our findings at our presentation of this material at the ASPRS MAPS Specialty Conference on 29 October through the 1st of November in Tampa, Florida. We will also post more information about this in our blog at aerialservicesinc.com in a little while. Suffice to say, some observations we've gleaned from this investigation are, first, there are currently few established manufacturing and safety standards. It's just too early. These standards will develop with time, and especially as FAA regulations materialize. Second, there are a large variety of designs. Lots of innovation is happening. Consequently, buyers have lots of choices. The downside of this, though, is that most UAVs have non-market tested performance characteristics. For these reasons, problems with the reliability and complexity of systems may be common. Eventually, we may see the consolidation of many small manufacturers to fewer larger ones, and common aircraft designs that provide more stability and reliability of the unmanned systems. A few of these, if any, had sense and avoid technology. They were all designed to be flown with line of sight rules. How much this will change in 5 years can only be guessed, but it will probably be quite substantial. There is still a considerable wait-and-see attitude within the mapping profession, however, because of these factors. So as I step back and I look at the development of this market, I see it being evolutionary until 2015 or so, then becoming very transformative after full integration with the national airspace occurs. We'll see many piloted aircraft now, piloted meaning not on the aircraft but remotely piloted, then more and more pilotless or fully autonomous UAVs, and then swarms of UAVs, both piloted and non-piloted, going into the future. There's a lot of work being done right now on swarming many small UAVs together that is very interesting and opens up many intriguing applications. The cost per flight hour is going to be the key driving statistic for commercial applications. Near term, now through 2018, we may see piloted aircraft we use today made to fly autonomously or remotely pilotable. For example, the Cessna 172 and the 208 Caravan can be made autonomous for under $1,000 today. we probably won't see firms buying Predators and Raptors anytime soon. However, we may see firms processing data from these aircraft for the entities operating them. That's a possibility. Longer term, we will begin to see commercial unmanned systems designed from the ground up for autonomous or remote piloting. What is exciting and scary to consider, though, is will unmanned systems become so small, efficient, and automated that non-geospatial professionals will operate them? Folks like farmers, pipeline operators, realtors, law enforcement, FEMA, DOT engineers, firefighters. That would be a game changer. It's impossible to say now, but it is likely that the short answer for that is yes. So the bottom line is that we've entered the dawn of autonomous flying sensors and have many reasons to be optimistic and excited about the many new markets that will be remotely sensed and provide new opportunities for professional service providers that simply don't exist today. Today, we can confidently say the value to our society of unmanned systems is indisputable. But because these technologies consume public resources, that being the national airspace and the electromagnetic spectrum for communication, federal regulations are needed to leverage the amazing potential of these technologies. Unmanned aerial systems will not simply be a replacement of our current tools, but a new way of approaching remote sensing. It will be more of an information and technology market. Lots of small, creative, flexible companies coming up with aerial platforms that, when combined with real-time wireless communications and cloud processing, promise to deliver end-to-end solutions. UAVs promise to provide more people than ever before access to affordable, powerful tools that can help them and their businesses become more productive. I am reminded of an accent I heard once, that if I don't automate, the other guy will. And we pretty much are going to be forced down this path. That concludes my presentation, and we have time for some questions. I'll turn this over now to Josh to handle the questions.
Great. Thanks, Mike. Really appreciate the presentation. We're already getting nice reviews from some of the folks that have attended, so a lot of great information there. Really thank you for doing that. So if you have any questions, feel free to put them in now. I have a number of them. I'm going to quiz Mike here in a moment. So this is your opportunity to get your question at this time if you have one for Mike. So Mike, I have a number of questions throughout the presentation. Let's start out with some discussion that came on early about just generally about accuracies or the ability of UAVs as we see it today to produce quality data. The first question that came in was, what about the quality of the IMUs that they're using? What about the abilities photogrammetrically to handle the data? And in addition to the hardware, then what does that mean for people like you who are a photogrammetric professional? Yep.
Well, a couple things. Today, the high accurate GPS and IMU devices that we put in our aircraft, cost on the order of $150,000 to $200,000, and they're big. They're too big to put in small unmanned vehicles. Those devices that we put in small unmanned vehicles today are the size of a quarter or a few quarters, very small. They don't weigh very much. They're not real accurate. They, by themselves, are not accurate enough to achieve the high accuracies that we like to have. However, there are other technologies. We can use photogrammetry and the intersection of lots of imagery over an area to photogrammetrically measure positions on Earth. So there are other ways to achieve high accuracies using inexpensive lenses and lots of repetitive imagery flown over an area to get some accuracy. So we'll see technologies like that. We'll see the technology of these small IMUs and GPS devices improve very rapidly over time to where I think accuracy will not be an issue for these small UAVs even 5 years from now, if it takes that long.
Great, thank you. A related question that came actually from the same gentleman was, what do you think is going to happen to the traditional big sensor people that we buy our sensors from today, the various manufacturers? How will they adapt to this? I mean, they have, of course, a lot of R&D in these things. Do you see them scaling down operations to meet some of these needs, or is it just the technology is going to incrementally get better and allow for them to do the similar types of technologies in these smaller devices? How do you think that will be new players?
Yeah, that's a really good question. It's hard to say. I think back to the engineers and water hydro engineers back in Einstein's day that were put out of work when you could buy cheap electricity off the grid and they didn't need water wheels anymore. It will depend on how quickly they can adapt their technology to these kind of new market opportunities. I imagine there will always be specialized applications for big, heavy sensors. For example, we're not far away from flying unmanned vehicles, larger unmanned vehicles, you know, up at 30 or 60,000 feet persistently. Perhaps these will replace satellites. So we'll have these big, heavy cameras we use today in our aircraft up in these unmanned vehicles flying all the time over vast areas of the Earth, taking high-resolution imagery instead of depending on satellites. So it's hard to predict with any certainty, but those are all technologies that these traditional mapping companies, mapping equipment manufacturers are going to have to cope with.
One other question that came in, Mike, maybe plays off what you just said about this continuous acquisition at high levels or anywhere within this airspace by UAV. You made some comments towards near real-time acquisition and transfer of data to some kind of ground station or whatnot, some kind of downlink. But a question about that specifically. Can you maybe flesh out what you're thinking, your futurist cap, and tell us what you were meaning by that?
Well, the military today is broadcasting across wireless communication channels real-time video, very heavy data sets. In the civil world, we don't have access to that technology that I know of, or if we do, it's extremely expensive. But those kinds of technologies will evolve and become more and more available and less expensive for the civil marketplace, and enable us to do some of that same kind of work where we're beaming from the aircraft straight up to the cloud somewhere, the imagery as it's being collected or shortly after it's collected, and we won't have to wait until the aircraft lands and we manually unload the data from the aircraft memory onto some other device. Now, I might just add that the FAA just gave its first civil certification to the Global Observer, an AeroVironment aircraft that's a high-altitude, persistent surveillance aircraft. It's been used militarily for some time, but they've just given it a civil authorization certification. So that's the first example of, you know, a larger aircraft that flies really high and it's meant to stay up high and just surveil for very long periods of time.
Okay, another communications related question. What have you heard about the command and control issues with regards to hacking these things, right? I mean, if you've got all these things flying around, that has to be a real concern, in addition to just being able to sense and avoid. But what about interruption or just static and the radio signals heading up to those things? Anything you've heard about that specifically, hacking or interruption of data signals?
Yeah. There's been a couple news accounts recently of folks that have hacked the signals controlling these things. That's probably true. It is true. It certainly is a concern. But again, there's ways to minimize that potential issue by scrambling the channels used to communicate with the aircraft back to the ground control station. These systems are used routinely with our military equipment. So there's ways to avoid that. Today it's probably easier to hack because there are no standards. There are no proven ways to do it, and so they're kind of open still and easily hacked, but that will change.
Okay, we're winding down our time, but we'll try to sneak in at least one, maybe two more questions, Mike. The next question I had on the listing here was, with regards to some systems that are already in place, the reference here is to the Gatewing aircraft, which you showed an example of in your slides. Since it's pre-automated, or pre-programmed and automated in how it flies, how does that relate to line of sight? Can that be flown now in an environment?
Yeah.
As long as it's in line of sight, or do you have the control of it, or what's?
Yeah. In the United States, yeah. So the Trimble, there are different rules in other countries, but in the United States, it can only be flown in line of sight. But you can upload to the aircraft in many small unmanned systems a flight plan that tells it to go fly here, then fly there, and come back and fly back and forth across the field or whatever. But according to the FAA, that aircraft would have to operate within the line of sight all the time, whether even though it's on a pre-programmed automated flight path, it still has to be within sight of the operator to fly safely.
Okay, Mike, we're going to sneak one more in, and then we're going to have to end it here today as we hit an hour. Question as to, in today, right now, how many of these things are being used for mapping? You showed a lot of military applications and things like that maybe have a mapping element. But because of this FAA restrictions, are we just not set up for this, or is this, what's going on right now, if you had to give a guess?
Yeah, right now there's a number of small vehicles being used for research purposes, which include taking imagery, geospatially referenced imagery for a variety of mapping applications perhaps, but it's all being done in different government agencies and research institutions. There's no commercial mapping being done right now because it's not allowed.
Great. Thank you, Mike, for taking the questions. And I thank all of you for attending. Do not forget to fill out the survey as you leave the session today. It will appear on your screen. And we thank you again for coming. Look for our upcoming fall webinar series. Visit aerialservicesinc.com/webinars to learn more information about that as we move into the fall season. Thank you again, and we'll talk to you again soon. Bye now.